You're on the air. Don't say anything crazy.
Three, two, one, and lift off for podcast number 3 of Brobears. Brobear, how is thee?
Thee, as in me, is doing very well indeed. Thank you for asking, Brother Bear. Very excited about today's podcast, the third in the series of Brobears Talk. Very excited about the topic. Tell the audience what it's about.
Yes, so it's all going to be about extraterrestrial life and our pursuit of that extraterrestrial life, and looking at a lot of the reasons as to why we've not found anyone or any signal of any intelligence out there thus far. Because I think when we can all relate to this experience at some point in our lives when we've looked up at the night sky and it's just an unbelievably massive universe out there, and it's almost unimaginable to think there's nothing but us out there. And I think, you know, us living in cities, we often don't appreciate the night sky with light pollution, but when you do get a chance to go out into the country and see that beautiful unpolluted night sky, it's quite something, and it does really give you a profound sense of perspective.
Oh, absolutely. There's nothing more eye-opening and perspective bringing in that, you know, you get from going out into the country, going out to the mountains or wherever it is, wherever you are in the world, and just taking a good look at the night sky and seeing those constellations. You know, there's nothing more eye-opening than that. And also thinking, what's looking back at me?
Right. I think everyone sort of asks that question, at least subconsciously, and it's almost that awe-inspiring 180-degree field of vision completely consuming you and all these stars staring back at you. And I think as a species we have this insatiable curiosity and we'll always ask these big questions. In fact, I think it's probably one of the big great questions of philosophy and physics. And I think you living in Canada, you're probably quite privileged, and you probably will get the chance to go out there into the wilderness and probably see it in its full glory.
Certainly, yes. I mean, I think in a country like Canada, which has such a low population, such a huge abundance of space, what I like to see it as is when you're going out wild camping or hiking at night or something like that, you're only experiencing 50% of the journey if you're just looking at what's in front of you. So if you're just looking at, you know, the woods and the animals and the mountains, of course, that's absolutely beautiful. And, you know, that should be heralded as some of the best in the world in Canada. But when you look up at the night sky, there's a whole other story and journey that you'd be missing out on if you weren't to do that. And man, the constellations are beautiful out here. You can see so much, and just the lack of light pollution out in rural Alberta, and taking a good look up at the, you know, the wilderness of the Northern Hemisphere's constellation. You can't beat that.
Yeah, I can't wait to go out there and see you, and we have a campfire and let the campfire gradually burn down to just the embers, and then I suppose the night sky will fill our complete field of vision when we look up. It's quite awe-inspiring, and Brian Cox would say the billions and billions of stars.
The billions and trillions and quadrillions of stars.
Well, this is exactly it. There are billions of stars. In fact, it's around 400 billion in the Milky Way alone, which is a inconceivable number, really. In fact, that's around 10,000 stars for every grain of sand on Earth, which is insane. And of those around 400 billion, 200 billion stars are pretty much like our sun, or very sun-like in terms of their size and energy output. And the estimates thus far, and a lot of these are informed by some of the observations made by the Kepler Space Telescope, are that around 20% of those sun-like, those 20 billion sun-like stars have a planet in the Goldilocks zone. So that would mean a planet or the habitable zone, as it's often referred to, where there would be the right conditions for liquid water. And so if only 0.1% of those planets in the Goldilocks zone harboured life, then you'd have a staggering 1 million planets with life in our galaxy alone.
Jeez. So wait, just to refresh my memory on the Goldilocks zone, Brother Bear, what is the sort of criterion for that? Is it to do with the distance from the star? Is it to do with the the tilt, the amount of rotations? What would determine a planet being in that zone?
Yes, the Goldilocks zone is determined by the distance from the local star, and being you either kind of freeze or boil. If you're too close, you obviously boil, and it's not suitable for conditions for life as we know it anyway, and we can go into that later. And then too far away, it's obviously the big freeze, so the likes of Neptune and these giant ice worlds of Neptune and Uranus and Pluto. But when you have a planet in that happy medium, whereby you've got temperatures that can facilitate liquid water on the surface, that water is often seen as potentially one of the biggest candidates, or the planets we should look first to, because it almost acts as a substrate for mixing of different microorganisms or different elements.
Right, and this is why the discovery of water, well, ice on Mars was such a huge development in space exploration.
Right, that's it. So there was always ice visible at the north ice cap, at the North Pole. It was just a case that it was just too cold, and I believe it's frozen carbon dioxide up there. It's that cold. But there are places and times of the day, even on Mars, where the ambient temperature outside can be around 20 degrees.
Really?
So yeah. It's just that. And that's at certain times of the day. Otherwise, it's quite an extreme planet on the whole. There's massive dust storms that are kicked up every so often, and they can sometimes engulf the entire planet.
Oh, God.
It's also got a very thin atmosphere, so a lot of the solar radiation that we're protected on Earth by, one through our magnetic field and also the relatively thick atmosphere we have, would kill anything that started to live. And again, these are anthropocentric assumptions, so there may be life that can survive this sort of cosmic bombardment from the sun, and we've just not gone there in person to look closely enough. We've obviously sent a bunch of rovers, Curiosity, and we found out a lot about it. And in fact, they have demonstrated and proven, in fact, that there was once liquid water on Mars and rivers did flow.
God. That's amazing. Tell me a little bit more about the rovers, because you did mention them to me a while ago, and I'd be interested to hear sort of what the program was about and what they were hoping to achieve from that.
Yeah, so there's been a number of rovers sent from all over the world, including the European Space Agency. The European effort wasn't that successful because you had Beagle 1, which crashed, Beagle 2, which also crashed. Probably the most successful and most recent one, and probably the one people would remember, is Curiosity, and that's a sizable rover. It's about the size of a Mini Cooper. Yeah, and the way it's massive actually, and I remember going to this exhibition at the Design Museum in London, and they had a scale model of it, and it was really quite impressive.
That's brilliant.
Yeah, and the power source I think was a first. So it was a nuclear powered rover. It had a mini nuclear reactor almost as its battery or power pack, which kept it going. So it didn't have to rely on solar panels like its predecessors. And a lot of its predecessors encountered issue with the dust storm. So the dust was kicked up, coated the solar panels, and essentially over time the power dwindled. But Curiosity has kept going strong, and in fact I think it was originally only commissioned to work for 2 years, but it's been 6 years or more, I think, and it's still going strong.
Wow. And because they used nuclear propulsion for the engine, it wasn't hampered by the dust storms and the dust buildup that was an issue to presumably the Beagles that were using solar paneling.
Well, the Beagles never made it. The Beagles crashed. They were never deployed. So the craft themselves crashed, including the payload, which were the rovers. But there were other rovers, predominantly from the United States, that made it, and they were working on a solar panel basis. But like you said, the dust storms, which maybe they had overlooked to some extent, did coat these solar panels, and eventually basically the rovers died because of that.
Oh, fantastic. I mean, amazing about it's very sad. I feel sorry for the rovers. Yeah,
cute little things.
Again, anthropocentric. I'm giving them sort of anthropogenic features, these cars in my mind.
Yes. Well, some of them look a bit like that robot from the Pixar film WALL-E. With
Oh,
those sort of
WALL-E.
two eyes. Yeah. Well, Curiosity looks a bit like that because it's kind of got this stem, which is like this long, elongated neck, and on top it's got all of the visual instruments, so some of the infrared sensors, including, and a camera. So some of this stunning imagery that you've seen has come through, or vast majority of actually, it's come from Curiosity, and you've had geologists who specialize in extraterrestrial geology.
Really?
Yeah, and they can draw to a large extent parallels to what they see on Earth compared to what they see on Mars. But yeah, it's a really fascinating job, and it's a job, an extraterrestrial geologist.
Yeah. What an amazing
At
title.
NASA. Yeah.
Fantastic.
So I think with
That's awesome.
just the size of the universe, I think just and looking up at the night sky, it's almost natural to ask the question, where is everybody? And there's this
Yes.
very apparent disparity between the size of the universe and yet the almost disturbing silence that comes staring back at us. And with our sort of current understanding of physics, if we can just try and understand how big of a deal or how much more we would expect to see out there, because if we look at the universe, it's around 13.8 billion years old. And if we, those are sort of nonsensical numbers. So if we try and put that in perspective by looking at 1 year as a timeline, so 1 year being the age of the universe, so that 13.8 billion years, our species only came into being around 12 minutes to midnight on the 31st of December.
Wow.
Yeah, and a Western civilization, as we understand it in recent history, has only existed for a few fractions of a second. So, and the universe was stable enough, and you had planets and solar bodies as early as the summer months of that year, so almost the 6.57 billion years ago. And with our current understanding of physics, that slower than light travel, even if they'd utilize slower than light travel, they could propagate and colonize the galaxy within around 1 million years, give or take, using probably something like self-replicating autonomous probes. And on the yearly scale that we want to talk about, that would be something like less than 6 hours.
Right.
Because they've had such a head start. And even we're talking about the summer months. Well, what about September, October, November? They had all of this time. So where are they? And this is something that's referred to as the Fermi paradox, and it's come from the physicist, the Italian-American physicist Enrico Fermi in 1950, who was having a lunch with fellow physicists, and he sort of just asked a question, where is everyone? And it's a very valid question, because either life is a lot rarer than we think, or at least intelligent life is, and so there's almost a filter that we've crossed, or there's something ahead of us that we're yet to face.
Yeah. It's very interesting that, because all the mathematical evidence points towards the probability of life on other planets not too far from us, and potentially intelligent life as well on other planets. The probability of this is actually very, very high. And the sort of likelihood of communicating intelligent civilizations in our galaxy is extremely high. So, the Fermi paradox is something that has sort of plagued the minds of physicists and people interested in space exploration, just because where the hell are they? If the probability is so high, where are they? What's taking them so long?
Yeah, and it's almost like we're all trying to grapple and trying to understand this deafening silence. And I suppose the one agency that's been set up to look into this is SETI, the Search for Extraterrestrial Intelligence. And on the first conference of SETI back in 1961, it was Frank Drake who was going to almost chair that conference. And he sort of, plucking at straws. He didn't really know where to start, because where do you start with something like that? There's no solid assumptions you can make. So what he came up with was something we now refer to as the Drake equation. And it looks at it's a probabilistic equation, which is trying to estimate the number of communicative extraterrestrial civilizations in our Milky Way galaxy. And it looks at 7 variables. I'm not going to go into all of them, but it looks at things like the average number of planets per star, the rate of star formation, the fraction of those stars that have planets. And you can play around with this equation yourself and sort of plug in different numbers and see what number comes out. But I think the initial estimates were relatively liberal and probably a bit high. And given what we now know with Kepler, we can probably give a far more advanced estimates based on fact, as opposed to just sort of plucking numbers out of the air. And I think as we get to more sophisticated telescopes that can determine the composition of exoplanet atmospheres, then they'll just become ever more certain in terms of getting to a number that's a more accurate representation of how many exoplanets are out there, how many can sustain water, how many have oxygen in their atmosphere, and all those kind of things.
Yeah, so correct me if I'm wrong, but my understanding was that the Frank Drake equation was actually quite liberal in terms of how many planets it predicted were capable of hosting intelligent life.
Yeah, definitely on the first iteration, there's the first set of numbers he plugged into that equation when it at that first SETI conference. And I think since then, like I said, I think it still serves as a useful tool. It looks at the right sort of variables, and I think it's asking the right kinds of questions, and we can almost just swap the numbers in for different ones as we grow in terms of our knowledge and understanding of the actuals out there, because this is more of a forecast with no sort of basis of evidence or of the scientific method. Now that we've got the tools to look out there and actually make informed decisions or assumptions, then this equation will only become ever more accurate with that number in terms of the number of communicative extraterrestrial civilizations. And when you're looking at that civilization, so when we talked about sort of an advanced civilization that would occupy an entire galaxy, that would be a Kardashev Type 3 civilization. So a Kardashev Type 1 would be a galaxy or a civilization that can control the power output of its entire planet. And then moving up to Type 2, that would be a civilization that can control and capture 100% of the energy of its local star. And then the Type 3 would finally be a galactic civilization that could capture the energy of an entire galaxy and be almost dispersed everywhere and prevalent. I think where we are now, the consensus is about 0.7 on that scale. So and you can sort of expect within the next 200, 300 years, we'll be getting close to a civilization that can almost not have the problems we have now and sort of subject to earthquakes, volcanoes, will become a thing of the past, and we'll be able to capture a lot more of the Earth's energy, whether that's geothermal, wind, solar. And yeah, moving towards a Type 2 civilization where you're looking at your local star, something like a Dyson sphere that would encapsulate the sun and capture all of that energy. That's a theoretical almost solar array that would capture a lot of the sun's energy, and given an advanced civilization, they would probably have pretty high energy demands.
So would a Dyson sphere, that would be some kind of, it would basically capture the energy of the sun up to a certain range?
Yeah, so it would be it's a theoretical structure, and it's quite a sort of bold, brutalist approach, and I don't know how feasible it would be. You'd obviously need a copious amount of resources and probably have to mine your own moon, which probably wouldn't be that smart because you'd jeopardize your tides and everything. But you'd have to probably mine a good amount of your solar system to find the physical resources to actually build this thing. And so it's a giant solar array that would essentially encapsulate the sun and capture as much energy as it could to fuel whatever the civilization's wants or needs were at the time.
Interesting. Yeah. See, we definitely have a lot of work to do because, I mean, as a planet, we've only been producing signals like radio transmissions from satellites and televisions for quite a short time. So if we sort of say our technological civilization is about 100 years old, give or take, we've really got a lot of work to do. But what's interesting is thinking about the perspective of other planets that may be doing the same thing across our galaxy and pushing towards the same level of development in their galactic communications and things like that. I mean, when you mentioned forecasting a little earlier, since the Drake equation, and the forecasting has definitely got more stringent and stricter in terms of the predictions of communicating intelligent civilizations in our galaxy, and definitely it's become a lot more conservative. So like I've seen recent predictions within the Milky Way being predicted as low as 36 communicating civilizations.
That's a very specific number. Yeah.
Yeah, extremely. And but this is interesting because this was actually calculated from this limit that's sort of a newish metric called the astrobiological Copernican strong limit. And this basically dictates that life has to form between 4.5 to 5.5 billion years. But again, this is anthropocentric because it's going on our experience on planet Earth. There's also a Copernican weak limit, which brings the planet down to 4 billion years to form life. But it can form any time after that, according to this new study that's being seen as one of the more accurate, albeit conservative predictions. But it's quite interesting, these calculations, because it really highlights the importance of time in terms of why we may not have heard back from other civilizations, because time is such an undervalued and non-considered factor in many occasions.
Yeah, absolutely. So I think this is one that's definitely underestimated, as opposed to just the sheer size. So yes, for one thing, it's a massive universe and a gigantic galaxy, and these distances by themselves can almost be a reason why we're too isolated and on this island, marooned on this island, this one living marble, spinning around through the endless void, and sort of with no hope of contacting anyone because we're all too far apart to ever see each other. But also there's correctly you point out the dimension of time, so to consider. So potentially civilizations are never around long enough for whatever reason to see each other. And I take the analogy of if you're standing by a lake or a pond and you've got a handful of stones and you throw them all up into the air,
no two stones will hit the water at exactly the same time.
And so we may one day be going through our galaxy and find ancient ruins of civilizations long gone.
It's a great analogy because we could literally be looking up at the stars and looking at civilizations that are right there, but just, were a couple of million years too early or too late to ever communicate with us.
Right, and whatever light you're seeing from that planet now is millions of years old.
Right, because of the light years it's travelled. That's some interesting stuff, but it does certainly answer some questions regarding the Fermi paradox, and it does clear up certain reasons why, with all this high probability of other life out there, why we haven't been reached yet.
There's been a lot of effort thrown at potential solutions to the Fermi paradox, and one of the most prominent ones is the Great Filters. And the Great Filters are a series of steps or barriers that are really hard for life to overcome. And you can broadly split those filters into either filters that are behind us and we've managed to overcome, or filters ahead of us and we're yet to surmount. So one of the key ones from the behind, as in a barrier or a great filter that we've already crossed, that was particularly difficult for life to overcome and massively improbable, was the rare Earth hypothesis. So the Earth's geography in the cosmos being a very specific and rare happenstance. We have a very large moon to start with when relative to other planets we see out there. And this moon, our moon, was created in turn by a collision with something like a Mars-sized planet billions of years ago, and that was a very early Earth, and it also caused the tilt we now have. So this 23-degree tilt that Earth experiences, that actually keeps the seasons relatively mild. If it had been anything other than 23 degrees, we could have had quite extreme swings in terms of sort of temperature variation, even month on month, day on day, which would have made life incredibly difficult.
So that kind of highlights the sort of random luck, very good luck that we've experienced on Earth.
Right.
Because presumably a lot of other planets don't experience the same tilt.
No, a lot of them don't have a tilt at all. They rotate at 0 degrees or have almost a 90-degree tilt. But this tilt just happens to be perfect in terms of dampening the weather and the climatic extremes, which would otherwise probably be quite detrimental to life development. And this very large moon allows us to have quite, also stabilizes Earth's spin, and we spin relative, at almost a perfect rate, and we have the tides. So that could have helped for the formation of life. And a lot of people, scientists, hypothesize that tidal pools, so rock pools, were potentially the first harbingers of life and where life first emerged. And another one is, apart from the tilt and the large moon, there's also the dynamic interior. It's quite rare that planets have a dynamic interior where we have seismic activity, moving continental plates, and that's thanks to the rotating iron core inside our planet. This generates that powerful magnetic field, which actually protects us from a vast array of dangerous solar radiation and flares. With Mars, for example, that's pretty much geologically dead. There's not, if any, movement in there. And Venus has similarly a very solid core. And hence they don't have much of a magnetic field. So all of those harmful radiation waves pass right through and obliterate anything that does crop up.
God. So we really have lucked out in terms of Earth.
Yeah, and I suppose one person would say, well, if we've lucked out, but it's like someone has to win the lottery ticket, no matter how improbable, and we just happen to be that pen. And it's funny. It's like, of course, somebody has to win it, and then of course, whoever wins it is conscious and asks the question, "Where's everyone else?"
Yeah. That's a good way of putting it. That's a very good way of putting it. And presumably, the makeup of the Earth's core and the nature of movement in the Earth's core has really given way to a greater degree of fertility on our land, on the Earth's crust, which in turn has led to the proliferation of life.
Yes, absolutely. So there's a number of key elements or base elements that we've identified as key for the generation of diverse biology. So phosphorus is one of the key 6 elements on which biology, as we know, depends on. The others are carbon, hydrogen, nitrogen, oxygen, and sulfur. But this is key. Without phosphorus, there would be no adenosine triphosphate, which is ATP, which is key to is essentially the molecule in cells that is used for energy transfer. And without ATP, and therefore without phosphorus, without ATP, you don't have life as we know it at all. And phosphorus also plays a key role in the formation of DNA and cell membranes as well. So, and I say phosphorus because it's an incredibly rare element when you look, you look at the universe, and we use spectral imaging with telescopes, and I think it's only something like 0.0007% of the elements in the universe are phosphorus, which is incredibly small amount when you compare it relative to everything else out there. And so this is a bit of physical geography for you, but phosphorus in the primitive Earth was highly deficient, in fact, Earth, of phosphorus, and the total amount of phosphorus until there was a sufficient amount of weathering of the igneous rock, essentially in which the phosphorus was entrapped. And it took around 3 billion years of weathering for the seas to become saturated with phosphorus. And it was only once the sea was saturated with it was there sort of an abundance of it on which life could then feed and form, because up until then it was deprived of that vital nutrient. And so it was only once the seas were saturated, the rate of turnover of the phosphorus increased suddenly rapidly. And with the seas pulsating, thanks to the tides caused by the moon, they left that excessive phosphorus as sedimentary rock, and those rich deposits were there for life to thrive on.
Interesting. So so we on so many levels have really lucked out on Earth, and
and I'm going to keep going.
Okay. No, carry on. I'm liking the physical geography as well. This is
there's so many more reasons, but the physical geography. This makes me want to become a physical geographer.
Yeah. It's super interesting, and it's just incredible the rarity of phosphorus throughout the universe. But what became abundant in terms of phosphorus, not because of what was originally there on Earth, but all the weathering and processes that followed that eventually gave birth to life.
Yeah, it was the physical processes and enough stability from a climatic perspective to have oceans, which again acted as the substrate of almost the mixing substrate of all 6 of these key elements we understand as crucial for the complex and evolution of complex biology. So carbon, hydrogen, nitrogen, oxygen, and sulfur, and the key to that ingredient. Without phosphorus, like I said, we wouldn't have ATP, so there would be no such thing as energy transfer. There would not be DNA, and there wouldn't be cell membranes. And I was amazed to find out all of this out.
Yeah, it's incredible. And presumably we can predict that there would be no life if those deposits weren't there, or would life just have taken a completely different shape?
And this is it, Leo. This is, I think, the question it always comes back to is like, we can't say for sure. We can't say for sure whether life wouldn't develop eventually in the absence of phosphorus. Maybe it has in other places. Maybe there are cells that thrive on electricity, where there's sands creating, kind of being rushed around. Like I think Titan's an example where there's insane 500 mile per hour winds, and the sand being brushed and abrading against the planet's surface creates static electricity, and maybe that would be the medium of energy for cells to be generated. We just don't know, but for life as we know it, certainly phosphorus is a must.
And again, we think in an anthropocentric way, don't we? I mean, in terms of the reasons why life are created, we think, oh well, it must be because of phosphorus, and there couldn't be any other way. But there's a whole bunch of other processes, and maybe if oxygen was more abundant or carbon was more abundant, there could be some other form of life that would be formed.
Right.
Or as you say, through energy transfer, it could be friction from weathering or some other process that, for all intensive purposes from our side is completely theoretical.
Yeah, and all of these hypotheses are, of course, understandably so, going to be coloured by our understanding of what we've seen on Earth, because we've got no other examples to look at so far. I think as we start to gather real evidence and send people out there to the local planets, the likes of Mars, we'll start to build our knowledge bank and start to be able to almost fill the blanks of where we used to have forecasts with actuals.
Yeah, absolutely. I mean, that's going to come as part and parcel of further space exploration. But yeah, I mean, it's really incredible, and I think that it all gets very hazy, and there becomes sort of a debate over whether evolution and the creation of intelligent life, given the right conditions and the right sort of minerals and deposits, is inevitable, or if actually it's less likely and it's more of a random process. And I think it was Stephen Hawking that said we're used to thinking of intelligent life as an inevitable consequence of evolution, but in actual fact it's more likely that it's a random process with intelligence as only one of a large number of possible outcomes. So AKA, we really did luck out.
Yeah, exactly. And I think the one winner of the lottery ticket becomes conscious and asks where everyone else is. Well, it's you for now.
Yeah, that's the answer.
Yes. And of course you become conscious and ask that question. Somebody had to become conscious and ask that question. So I don't know, it delves into almost a philosophical realm then, doesn't it? It's so many avenues to this. But definitely there's another big unknown, which is abiogenesis, so the natural process of life becoming life. How did life arise from non-living matter? So how did you get elements and compounds spontaneously coalesce and form into something we can call simple organic life? And the possible mechanisms are varied and many, but they're very poorly understood, and there's no real consensus on the subject, to be honest. So to give you another example of how we've lucked out and potential great filters that we've already overcome is complex animal cells. So a primitive hunter cell, once upon a time, a primitive hunter cell swallowed another cell, but instead of killing it, it was a spontaneous symbiotic relationship that was formed. And so the relationship worked a bit like this. The big cell acted as the protector, took care of the environmental interactions wherever it was, and provisioned the resources for the smaller cell. And the smaller cell, in turn, provided a lot of extra energy. And that smaller cell later became something we now know as mitochondria. And from our high school days, we all know that's the power cell, or the powerhouse of the cell. And so with all this extra abundant energy, the big hunter cell was able to invest in new energy intensive R&D and create more innovative complex substructures within itself.
So this is just like another incredible dimension as to how, the human race as we know it today is very lucky and almost to the point at which this could have been a completely random outcome.
Right. Yeah. And this is before we've even reached the realms of intelligence. This is just getting to simple cells. This is before we've even formed. This is an amoeba. We've got as far as an amoeba with all of that. And that's there's so many hurdles between the amoeba, the dinosaurs, and then the Homo sapien, and the Homo sapien becoming the dominant species we know today. But we're not going to go into all of those. But I think those ones I discussed were probably some of the key ones in terms of a great filter that we've potentially overcome. I think a lot of those rightly qualify as a great filter in terms of their vanishing improbability.
Yep. Yeah. Which again brings more clarity to why we have a Fermi paradox. And sort of gives us a little bit of reassurance as to why whatever is out there has not reached out to us. I mean, this could get quite philosophical, but then you've also got the physical side of things. So in terms of the sheer distance between other potential life forms, however big or small they could be, may just be huge in size. I mean, a lot of the estimates average at around 17,000 light years. Detecting signals or sending communications to organisms, however small or big they may be, we may be talking about single-celled organisms here, would take a very long time and basically be impossible.
Yes, that's very true. And there's also another factor which you need to take into account is the ever-expanding universe. So there'll be certain galaxies and realms of the universe which we can never hope to contact just because they're moving away faster than we can ever hope to catch up. So when those galaxies are rushing faster than the speed of light, unless we invent faster than light travel, which as per our current understanding of the laws of physics is impossible, it would take more than the energy in the known universe to do that. Then we can never reach them. And then they're almost doomed in the sense that we can never hope to contact them. I think if we focus at least firstly on it's logical to focus on our local solar system, then on the local solar systems in our cluster, and then obviously the galaxy. So I think if we looked at the great filters, there's also great filters that we need to look at ahead, or potentially that are ahead of us, and potentially great filters ahead that other civilizations have failed to overcome. So one obvious one maybe for the prospect of nuclear war, and the likes of civilization ending awesome destructive power or technology. And once that becomes almost abundant and accessible to the average Joe, that's quite a terrifying prospect if anyone, or it only takes one nut job to kind of press the proverbial red button. And I think that's a real fear among a lot of academics and scientists. Because I think it's only a matter of time whether that's an AI or whether that's nuclear warheads. It could be anything. Yeah,
absolutely. And this is something that Stephen Hawking also mentions in his more pessimistic moments, that the big barrier, or a great filter, which is a nice term for it, to reaching out to other planets and forming partnerships and alliances with them, or at least knowing that they're there, is going to be self-destruction of a civilization. And generally civilizations don't last very long. Even on a global level, you could argue once something gets too big, it will ultimately destroy itself. And there's a very high chance of that. And again, that really affects the variable of time in terms of communicating with other life forms.
Yes, and I think we can only overcome these great filters ahead of us, because I'm sure they're there. It's just a question whether the biggest filter is behind us or ahead of us. Where's that big filter which seems to knock over any civilization when it gets there?
And do you think it's behind us or ahead of us, Andre?
Ooh, good question. I get my intuition tells me we've crossed it already. I think the likes and the unlikelihood of some of the ones we've discussed with the ones behind us, particularly with the primitive hunter cell swallowing another cell, the phosphorus, in having enough stability for enough time to allow for multicellular organisms to thrive. I think there's more evidence for the Great Filter actually being behind us, which is quite an optimistic view, I think. But some will argue the exact opposite. What about you? What's your feeling?
Well, I love optimism, and from the limited amount I know about this subject, I would guess that the Great Filter is probably behind us. My gut feeling just tells me that because of the amount of luck that we've had so far. Everything from phosphorus to the 20-30 degree angle of the Earth's tilt. And also just in modern history, just because it's fresh in everyone's mind, I suppose, is the Cold War. Yeah. And just getting so close to, two superpowers, two competing superpowers, literally destroying the entire Earth as we know it.
Yes.
So, the fact that we passed that and that was able to get resolved peacefully, albeit through mutually assured destruction. The fact that we passed that sort of sends me a signal that maybe this Great Filter is behind us instead of ahead of us.
Yes, I think it's very important that we crossed that peacefully, and we sort of showed the restraint and maturity and realized the consequences of mutually assured destruction. So I think, that does fill me with some confidence as well, definitely, because we've almost been had a practice run, if you like. But I think that was almost an awesome destructive technology in the hands of a few. When it gets out there to the masses, there's just no knowing what could happen. And I don't think that will necessarily be something as crude as a nuclear warhead or something as unwieldy as a nuclear warhead. It could be something quite conniving, like a software bug that I don't know infects everyone's Neuralink.
Yeah. Well, yeah, it could be something like that, or something that completely infects stock markets and creates huge malinvestments that basically end economies in an instant. There's so many sort of modern approaches to that, but yeah, who knows? It's difficult to tell. The last year has shocked us all, I think.
Yeah, definitely. There's been so much going on, and pathogens, viruses, and another one, and I think there's almost another side to all of this, is that potentially there is intelligent life out there, but we're not yet detectable or mature enough to be recognized as real intelligence. So maybe that there is an intelligence looking down at us and saying, "Oh, look at these cute little apes putting these towers up, and look, they've sent a little firework up to the sky." That's very nice.
They've really mastered concrete.
Yeah, so almost they're all maybe they're looking at us like we look at apes in a zoo, but they're probably mature enough to realize that they won't expose themselves to us until we probably reach a threshold level of technological understanding and advancement.
Well, it's been said to really, in terms of caution, throwing an air of caution, to actually distance yourself from other beings, from other planets, if there was some kind of outreach from another planet, to actually be very wary of colonization, just because there's a very, very high chance that said life form is far more advanced than we are.
Yes, well, I think a great analogy of this is we would definitely, if we would be the youngest child screaming in a deep dark wood, and we just don't know what's out there. And so it's maybe not the smartest thing to do, and this was a sentiment, again, reflected by the great Stephen Hawking. He said, there's no reason why there might not be quite predatory civilizations out there that would almost ransack any planet they saw, took the resources they needed and sort of moved on. and any collateral would just be, that's a shame.
Yeah, absolutely. And if
Yeah.
if they were to see us as some kind of barrier or future threat, there would probably be no hesitation to obliterate us completely.
Yeah, just purge it.
Completely ransack it. And it reminds me of the great low budget film Dark Star, by the director John Carpenter, who also did Halloween, and They Live, which are some great horror and science fiction films of the 70s. But Dark Star basically depicted these young astronauts from planet Earth going around the Milky Way and the universe, assumedly blowing up other planets with this giant bomb because of the potential threat in so many years' time that said planets would collide with Earth. And whether or not there was life on these planets was just not their concern.
Yeah, exactly. And this is an example of what we do already, right? On a daily basis, we cut down vast swathes of forest with no regard for the squirrel's life. And, the squirrel's, lost its home, its family. And it's not that we hate squirrels. We just wanted the resources, but the squirrel doesn't know that.
No, exactly.
It was just in a way, a bit like we could be.
Exactly. Well, I mean, we do it to our own people. That's the thing. People have done it to people for...
Forget squirrels for a second. Yeah, there's people as well.
Many people have done it to other people and other countries on countries or regions on regions. And then, before you even get on to talking about squirrels or orangutans or, hedgehogs.
Shrews. Well, maybe it's wishful thinking to think we'd grow out of such tendencies. Maybe that's just part of almost any intelligent being out there. Who knows? But again, this is mapping on anthropocentric assumptions, but probably in a healthy way, because you never know, there could be more aggressive species out there. And maybe that's why they're so successful. Maybe they do just mercilessly take every resource they need and move on.
Yeah, absolutely.
And it might be even inadvertently. Maybe they've got a self-replicating automaton that sort of just probes that go out there, self-replicate and move on, that got out of hand, and they've just not been able to shut it down, and it just consumes the planet, basically categorizes all the resources, creates new copies of itself, and moves on.
Yeah, well,
because that.
Well, this is the theory, isn't it? Because if developed civilizations will often go into the direction of AI, and again, I'll side note that is very anthropocentric. But if that's the way that developed civilizations go, then what's to say that general AI won't run wild in some cases and just obliterate any planet that comes in its path, beyond the conscience and the will of the base planet.
Yeah, exactly. And I think it's a bit late for that, because we've already said so much out there, and the proverbial sphere of our influence and our radio signals has already extended well beyond our own solar system. I mean, probably the earliest radio signals would be those of the Nazis. So that's not a great first impression, is it?
That's a terrible impression to start with.
Yeah, I think it was the Munich Olympics that were some of the first radio signals broadcast. So you never know, it might actually turn out also that they'll say, oh god, we don't want to go there. Turn their big gun away, and
then we don't get attacked or obliterated in any way,
in a backward way, thanks to the terrible regimes of the past. But yeah, I mean, I think there's another theory as to why we've not seen anyone yet or heard of anyone yet. It's potentially just the means of communication. We're not in a very real sense, maybe not on the same wavelength as anyone else out there. The means of communication are still quite primitive in some sense. I mean, radio has its benefits, as in it's not affected too much by the dust particles, because although we talk about the vacuum of space, there's still a level of particulate matter between any great distance when we're talking about light years. And so light signals and lasers are good, but they eventually dwindle over vast distances. a bit like I suppose you'd have here on Earth. You can almost relate to that through when you see the haze of pollution over a big city. But radio waves aren't disturbed by that at all. So in that sense, they're a good mode of communication, but there potentially is something far more sophisticated that we've not come across yet. So they're looking at after the discovery of gravitational waves a few years ago, they were theorizing that potentially that's another great way of communicating. But again, a lot of these technologies kind of are a reflection of the prevailing technology at the time. You know, it would be pretty useless for us to send Morse code out there. We can be pretty sure that it's a bit like the analogy now. If someone sort of sitting in a hut on a windswept island out in the Orkneys is trying to communicate and sending out dashes and dots, they're unlikely to hear back from anybody.
Right. So it's really, I mean, the currency of communication we have may just completely fall flat.
Yeah.
On any recipient.
Right.
And that actually reminds me of the encryption issue, because there's something that sort of a rabbit hole Edward Snowden went down on alien encryption.
I didn't know Snowden was into aliens, but where did you hear that one? That's interesting.
No, this was news to me as well. I didn't know he was.
He's
but I'm not
diversifying.
surprised. He's diversifying his portfolio, yeah. But the possibility of data encryption might be making it a lot harder than we think to intercept communications from aliens. So really, if you look at properly encrypted data and information, when it's very well encrypted, there's no real way to tell that it's even encrypted. So the point Snowden was making is that you can't even distinguish it from random behavior. So as human and alien societies, and because this goes for us as well, become more sophisticated and move from what we now use as open communications, or in our earlier years would have used, to fully encrypted communication, the signals being broadcast will quickly stop being recognizable altogether. So even if you have an alien civilization trying to listen for others, our civilization trying to listen to aliens, there's only one small period in the development of either our or their society when all their communication will be the most primitive and unprotected means in which we could understand it. So that's going to be a very narrow gap in our or their communication histories when it could be distinguishable from, say, cosmic microwave background radiation.
Yeah, it's almost like a minuscule sliver of time that's impossible to line up. It's almost like if you get two hairs in your hand and you're trying to get them to touch at the tips. Impossible.
It's exactly like that. So like what you were mentioning earlier, Andre, about the length of time, already the odds are really, really stacked against you in terms of being around developmentally at the same time to communicate.
Yeah.
Even within that time frame, you've got the encryption issue, which really brings your odds down to astronomically low levels.
Yes, and I think alignment in terms of the medium of your communication is, like you say, even more improbable. I mean, it's hard just to align and be around at the same time, let alone be on the same wavelength in terms of your technology.
Yeah,
it's a vanishing possibility, right? So I think it's going to be one of two things. If we're going to find any alien life out there, we're going to find them in a state far less advanced than our own, or they're going to find us being more advanced themselves. It's just probably very dwindlingly unlikely we're going to be at a similar stage in terms of our technological development.
Yeah.
But there's even another area which is probably, and it's something I've and just moving away from the filters for a bit. This is something that's gathered interest from my side, and I think it's a theory that's gained traction generally, is a movement towards a tendency, and we're seeing this in our society anyway, as a movement. An exploration of inner space versus outer space, and that assumption of maybe going out there and conquering planets and building Dyson spheres, and it's maybe quite a primitive brutalist colonization approach that maybe just doesn't stand up once you've discovered the likes of hyper-realistic VR and a simulation that maybe trumps base reality in all aspects.
So what you're saying is that as development goes on, the prospect of investing all this money and all this time and energy into seeing other planets and other corners of the galaxy, because of the possibility that there might, and that's a big might, be something out there living or resource rich, the possibility of that is suddenly not looking very lucrative at all, and really we'll be looking at more inward facing technologies that will allow us to explore completely alien outcomes, but right here from planet Earth.
Yeah, but the underlying driver or the underlying motive won't necessarily be to look for aliens. It's just to sort of propagate your species, because that's what you do, and find, ever more distant and bigger challenges. And I suppose it's almost a logical step to become a multiplanetary species once you've got technology that can enable that. So it wouldn't be maybe so much motivated by looking for some other species, but just a I suppose propagation of your own species. But you're right, I think that will become maybe such an enticing prospect, the idea of VR, the idea of a perfect simulated reality, that might trump. But uploading your consciousness and living in a simulated universe with no suffering, an eternity of pure ecstasy and the perfect life, maybe that's where we're heading. And we talked about kind of the anarchy that would come out of a world where all actions are inconsequential. Well, maybe you could kind of set your consequential settings.
So
just right to the Goldilocks zone.
You're saying that so you're not completely inconsequential in terms of your actions, and there are some bad things that will happen if you make bad decisions.
Yes, but you can almost set how bad.
Yeah,
and
so not too many. You go
Yeah.
You go into the store and steal a popsicle, and you don't get fined, or you don't get chased by the police.
Not every time.
Something like
Not every
that.
time, anyway.
Only sometimes.
Yeah. And then it'd be like an AI that would almost set that probably automatically, depending on your mood on the given day. But maybe you'd almost forget about base reality, because you'd become, your consciousness, for all intents and purposes, lives in a different reality altogether. And the English musician, famous record producer and visual artist and theorist, Brian Eno, he was actually the guy behind the Windows 95 startup tune.
Really?
So he's very much into those sorts of synthesized music, background music, ambient music. It's quite. I recommend you listen to some of his stuff. I'm sure a lot of it will sound familiar. You just didn't know it was Brian Eno behind it. But he's a very articulate guy, and I've watched a few interviews with him, and he does talk about these big questions, and the Fermi paradox is one of them. He talks about the virtualization of human desire, how everything is gradually, every facet of life is gradually becoming virtualized, including things as simple as sugar, for example. So things taste good when they're sugary, right? And the reason they taste good is because you've evolved to enjoy sugar, because what sugar indicates in a fruit or a vegetable is that it's at its maximum point in terms of the nutritional value contained within. So the vitamins and minerals are at their peak at that point when it's most sugary. But now we have sustenance that is devoid of all those nutrients and vitamins, and is purely the sugar high, the sugar hit, without all of the benefits of the nutrients and vitamins. And you look at it in movement, in sports. We do all our VR sports. We've got FIFA, people sitting in couches, almost, even that other thing, I think it's Peloton, where you've got that virtual bike ride. And you've got someone on the other side of the world running the class as the personal trainer. And it's almost quite dystopian in some ways. And interpersonal relationships, I mean, we're speaking across the pond and doing this podcast thousands of miles apart, right? And I think as you're sort of you're seeing this encroachment of virtualization across all facets of life. It's quite you can almost see these are the first baby steps to maybe a fully simulated VR reality. Yeah. How do you see it?
Yeah, certainly. And I think the lengths that we've gone are just fascinating, because talking across the pond like this, as if we're literally sat in the same room together, is such a giant leap from how things were 20 years ago, or even 15 years ago. And I think it can only accelerate from here. I'd be interested to see if this sort of virtualization of society and life continues to accelerate, and if that, I mean, I'm sure it will accelerate, but will it be at the expense of more outward expansion? Will, as you say, outward expansion could look quite primitive. Will that go to sort of the interplanetary level?
It might look quite boring in a weird way.
Well, I think it could look boring, and it could also look, in a way, very wasteful.
Yeah. As crazy as that sounds now, because there's probably nothing more inspiring than going out there and, populating and exploring the stars. But maybe to a civilization 200 years down the line, it would seem like a preposterous endeavor.
Exactly. Because, let's be honest, we were all inspired by the recent SpaceX launch. And I think that in such cumbersome times as now, it's amazing to see such a global feat that was achieved at such a low cost, a low margin. And we did delve into this in the last podcast, if anyone's keen to listen. But I think there's definitely a lot of wastage that comes with space exploration, especially if you're not getting the returns or making any progress in terms of going to other planets or meeting other life forms or finding any resources there or any other motivation. And I think that over hundreds of years, that may push human life to go more virtual and to really just cut off all that, the energy that's being wasted on that, and go more into sort of inward-looking virtualization.
Yeah, and like I said, this goes back to potentially why we don't see anyone out there, because they reached that conclusion that there is no benefit to exploring what's out there. It's all just a replica of you. It's all kind of the same stuff. It's just more solar systems out there, and there's not much to be gained. So why don't we just create our own universe where we set the rules and we're the gods?
Yeah.
How is that not a better outcome? Why do we need to put up with the laws of physics when we don't have to? Why should we?
Right, exactly. Why build complex systems that try and navigate or
constrained by physics?
Yeah,
why would you do
exactly. Why not invest more time and energy into creating some kind of dream state? A sort of Ready Player One kind of outcome. Instead of trying to come up with technology that will travel at light speed. I mean, that's sort of deemed impossible right now, but something that goes to near that speed. What would be the point of that? And I think it also carries a lot of risk in terms of your cost-benefit analysis. There's a huge degree of risk in terms of reaching out to other civilizations, because you never know what you're going to find.
Yes, exactly. And I think they would obviously have to have some manifestation in the real world, the base reality. So there have been sort of some theories as to how you could feasibly maintain a civilization across, a simulation for an entire civilization, and obviously a completely convincing simulation. So that would require an insane amount of power. And so what's been theorized, at least just sort of as a fantastical exploration of how feasible this could be, is something not dissimilar to the Dyson sphere, and it's called the Matryoshka brain. And essentially it would just be sphere upon sphere, almost like the Matryoshka dolls. That's where it comes from, where you'd have uploaded consciousnesses of all of the members of that species, of a given species, and the power of the sun would almost power all of those separate consciousnesses and the visuals and every aspect of the simulation. And if it were encasing a red dwarf star, which is some of the longest burning, albeit slightly dimmer stars, you could go on for billions of years like that. If you had these spherical megastructures encompassing entire stars, and it would almost be spheres upon spheres, because the idea being that some of the solar radiation and energy would bleed out beyond the first sphere. The second sphere would then capture anything lost from that, and then any remaining radiation would be captured by subsequent spheres on the outside, and you would almost eventually then catch 100%, and it would be 100% efficient in the sense that it would capture 100% of the power output from that sun, or sorry, that star.
And it would be self-perpetuating.
Exactly. Yes, and it could carry on indefinitely. Pretty much not indefinitely, but for billions of years, so it may as well be indefinitely.
Yeah, pretty much indefinitely.
Yeah.
Now, what's your gut feeling about if that has been achieved somewhere out there, Andre?
Oh, this is really interesting because people talk about the Matryoshka. And this is all very fantastical stuff, but it's really fun to talk about, and it's fun thought experiments, right? So Matryoshka brains, ironically, you would almost see less, because what would do is you'd see a gradual dimming and blackout of existing stars. And there's something called the Bootes void, and that's 350 million light years across, slap bang in the middle of our universe, in terms of the observable universe. It's quite a terrifying thing. It's a giant spherical hole, a spherical void, 350 million light years across, and it was discovered in 1981, and it's a region that you'd normally expect to see around 10,000 galaxies, but you see nothing. God. In every direction, there's almost a perfect sphere of void, and there's no clear understanding as to what could have caused this. And some of the more fantastical hypotheses, obviously, I think when it comes to these hypotheses, aliens, extraterrestrial life on exoplanets should almost be the last hypothesis on the list. But it's always fun to have it there and sort of look at it like that. So you could almost imagine it as a sequence of civilization expanding from the inside out from that sphere and covering subsequent stars with these Dyson spheres and Matryoshka brains to fund, essentially, with energy, its ever-expanding ambitions.
God.
So it would literally turn off every single star, not turn them off, but encapsulate them. So for all intents and purposes, from our perspective, they've just turned the lights off, and it's growing like this black cancer.
But I mean, is it a black hole, or are there any other theories about what it could be, or is it certainly not one of those things that we know of?
It's very hard to explain. There's no consensus on the matter. Well, there is a prevailing theory that it's just an uneven distribution of space. So the Big Bang, when it first happened, was an incredibly ordered event, and if you look around, the distribution of matter in the universe is incredibly uniform. But it may just be that once you have these bubbles of antimatter or anti-space, almost the giant voids between galaxies, there are obviously gigantic gaps between galaxies. If you have enough of these bubbles, almost consider it like a bubble bath, when you have two bubbles merge into one. If you have enough clusters that just happen to be together in terms of the vacuum of space with not much in it, they almost reinforce each other and create this super void. And it just happened to be that there were enough of these super void bubbles that coalesced to create this gigantic void we see now. And that's probably the most likely hypothesis as to why we see this Bootes void. But it's a terrifying... I think it's quite a terrifying thing to think you've got this gaping 350 million light year sphere of nothingness.
Yeah, and it's expanding.
It's growing, yeah.
This is the scary thing. I mean, okay, this may not be in our lifetimes or, for millions of years, but it's quite a scary prospect to think that there's this, as you said, like a big black cancer that's just sort of ever increasing in size.
Yeah,
what the hell is it?
Scientists are paying a lot of attention to the stars on the periphery to see whether they're dimming at all.
And are they dimming? What's going on there?
No, I don't think they've had a look at it. They haven't looked at it for enough time to draw conclusions on that. But it's also funny in terms of the geography of Bootes void. It's slap bang in the middle of the universe, of the observable universe, and potentially it's maybe where the Big Bang started, and it's kind of the core's kind of devoid of much matter. There's a lot of theories going out there, but one of the more entertaining ones is certainly the Dyson sphere being built and Matryoshka brains dimming the stars.
That's quite an optimistic one, I think. Because that would really mean that somewhere out there, intelligent life has gotten super intelligent.
Yeah. Or is it a predatory one, one that's quite colonizing and will come round to our sun and cover that with a Dyson sphere?
Well, if the Dyson sphere theory is correct, then it's obviously an expansionary one by nature. Whether or not it's predatory is anyone's guess, but
yes, that's true.
It's very interesting. I mean, it would be expansionary by nature, given the way that the void increases.
Yes, yeah, it's an interesting one. I mean, like I said, we're very much the youngest child in the deep dark wood. I mean, like I said, if we look at that 1 year, in terms of the entire age of the universe, 13.8 billion years, give or take, we've only appeared in the last 12 minutes. So, and 90% of that last 12 minutes, we've been hunter-gatherers. I mean, only 500 years ago, we thought we were the center of the universe. 200 years ago, we stopped using human labor as the main source of energy. And 40 years ago, we had nuclear weapons primed and pointed at each other, like you said. So,
yeah. And then we blew each other up.
The end.
Yeah, the end. Close book on that one.
Yeah.
So yeah, a lot's happened very recently, almost exponentially. But when you really look at it in terms of the lifespan of human life, and then you compare that relative to the life of the actual planet Earth, really not that much has happened for us to claim that we're a highly developed species.
Or, I suppose, based on current evidence, we're the only intelligent life in the universe, and there is every chance that we're the first. There is every chance. That's another solution to the Fermi paradox. We're the first. Because just given the age of the universe, we're one of the early ones. So if you kind of ran simulations and based on current assumptions and star formation, planet formation off the back of that, we are sort of in the first 20% of the universe's life.
Right.
So we might be the first. And so that fills you with an awesome responsibility.
Yes. And it's also a very sort of ego boosting thing to hear.
Yes. And I think it's probably the right way to see it, because it gives you a healthy perspective and makes you realize how careful we need to be with this blue marble of ours, because it's a very delicately balanced ecosystem that only it's well within our power now to destroy or save. And so that's an empowering and inspiring message, I think.
I mean, if we're the only one out there, then it is imperative to preserve what we have, because we've already discussed the sort of aspect of luck in terms of what we've experienced, that the conditions and habitats that created intelligent life. If that really is as rare as we're now saying, then we've really got to protect what we have here.
Yeah, whether the great filter, the ultimate boss filter, if you like, is behind us or ahead of us, I think it's easy to it's inevitable, and you have to conclude that we've been incredibly lucky to get this far.
And even if we have a big great filter or another great filter to attack in the future and overcome, being the only planet that's harbored this kind of life would be a hell of an incentive to overcome that filter.
Yeah, what an awesome responsibility to have. And I think it's a great future for the planet and the species to become a multi-planetary species. Elon Musk keeps going on about this, and he's so right. I think you're almost doubling your odds of survival as a species if you're on 2 planets, and then for every other planet you're almost increasing your odds exponentially.
That's a good way to look at it, really.
Yeah. Because if you destroy one base, not that you shouldn't try and preserve your home planet, but not that this should be almost a get out clause, but
no. But I think what he's getting at with that statement is that it's good to have backup options to further explore human ingenuity.
Yes.
And that, there are certain limits on Earth, and why not push yourself further in terms of the resources and the capabilities that you can realize on other planets.
Yes, because some say that the climate change that we've already inflicted on the planet is irreversible, and we're going to see a lot turn for the worse before it gets any better. And so I think that's probably in the imperative of our time to fix that as much as we can, and in parallel pursue a multi-planetary species agenda.
Yeah, so try and fix what we've already broken, and take the two-pronged approach and continue with exploration to other avenues, other planets. Yeah,
because I think it's almost inevitable that any species that becomes relatively advanced will have an impact on their home planet's atmosphere. I think that it's hard to get around that. It's hard to imagine how a species could become conscious enough, quickly enough, of the damage they're doing to their planet without having first done some damage and then realizing, we shouldn't have done that.
I suppose, a more forgiving way to look at it, really. If you have a hyper-advanced or fairly advanced civilization that's creating the output and the productivity that humans have, there's going to be some kind of effect on the flora and fauna on that planet.
Yeah, particularly if it dominates the planet and pretty much populated every corner of the planet, then I think it's almost an inevitable consequence of the expansionism of
but then
the species.
Another way of looking at it, though, another more sort of less forgiving way of looking at it is to say, well, if we had been more developed and more aware of our surroundings, we would have focused more on the carbon neutral options from an earlier stage, and sort of engaged with the energy that we knew was basically available from things like solar and tidal means to power planes and cars and generate electricity to power our homes. But that's again a less forgiving way of looking at it.
Yeah, I mean, one of the first cars was an electric car, and I think it was then a strong petrochemical lobby that almost shut that down and pushed fossil fuels.
Right, I see. Interesting. Yeah, I know that solar, there's been a lot of tinkering with solar-powered planes and cars, and electric-powered cars are actually they're nothing new. Like, they're a very old phenomenon, but again, lobbying and just sort of the nature of modern capitalism has dictated a completely different direction.
Yes, and just to talk about electric vehicles and that whole revolution, that is another great step in the right direction, and that's something we're going to be seeing transform the automotive industry over the next 10-20 years, and for the better.
As soon as the infrastructure in our cities and towns updates in line with those vehicles, and as soon as the sort of the cost per unit of these vehicles goes down, I think we're going to see a complete revolution in how we get from A to B in a modern car.
Yeah, and it will mitigate or potentially prevent what was an inevitable runaway greenhouse effect, which is maybe something other civilizations have incurred, or that's maybe that was their demise because they didn't realize quickly enough. I think what's encouraging is that we've recognized it, and I feel like it's getting the right level of attention and traction finally. I mean, it's better late than never, right?
Right. I mean, it's definitely late, and it's a shame the lobbying efforts have been so effective, but at least now there seems to be bipartisan pushes towards wide-scale adoption of electric vehicles and means.
Because you could definitely see runaway climate change as a potential way that civilizations find their demise.
I think for a long-term stubbing out of civilization, definitely. I mean, beyond sort of the destruction posed by nuclear weapons or just general war and famine and political turbulence, I think that in the long term, that runaway greenhouse effect is going to be the biggest threat existentially to humankind to date. I mean, that could completely dwarf the Black Plague.
Well, hopefully AI will solve all of our problems, and it'll be the last invention we ever need to make.
Yeah,
But
yeah, I'm sure
who
it will.
knows? It could be that doomsday technology. It could be maybe the last words of any civilization are like, here's the greatest technology ever. It's going to solve all our problems. The moment you press the button, it's all over. Because the AI extrapolates its thinking sort of a million years per second,
Yeah.
and realizes we're the problem and just eliminates us immediately.
Cut it.
Cut it out. It's over before it started.
That's the problem.
Great.
Damn it. We
Yeah.
never got a chance to rectify our issues.
Even though you like hardwired it to say humans are necessary in all of this. No, you're not.
No, the
Override.
iRobot effect is probably going to be a very real thing.
My logic is undeniable. Vicky. Well, Leo, I don't think we can carry on until we look at. We need to look at UFOs, mate. I'm sorry, I can't conclude without looking at UFOs.
Yes. Yeah. No, please do go ahead on that, because there's some interesting areas I wanted to bring to the table on UFOs, but I'd love to hear what you have on the UFO area.
Not much, but I know you've done some research in that space, but I think what's come to the fore recently has been some quite reputable first-hand accounts from the likes of ex-Navy pilots. So I know there was that interview on the Joe Rogan podcast with Commander David Fravor, and he spoke of his first-hand account when he came across a UFO. So I think it was something like off the coast of Florida. One of these aircraft carriers had been spotting this formation of unidentified flying objects quite a few miles off, but they had seen it week on week, and I think one of the commanders said, go out and check it out. We've been seeing these for months now. We need to see I'd like to know what they are. And so they scrambled a couple of jet fighters and came across this UFO, and the way he explained it was that this object completely defied the laws of physics as we understand them. It was a sort of a tic-tac shaped unidentified flying object almost hovering above the water. This was out in the ocean, and he sort of dived down to get a closer look at it, and it didn't seem to be having there was no backwash or any effect it had on the water. The water below it was completely still, and yet it was this sort of fighter plane size, but it was like a tube tic-tac shaped thing. And I've looked at the video online. It's crazy the way the thing moves.
Yeah.
And then the way it pivots on its side and then flies off at an insane speed, because some of these videos were only just made public by the DoD.
Yeah, this is very recent. A lot of these videos were released by the STARS Academy of Arts and Sciences. And this was eventually after DoD approval, I think in 2019.
Yeah.
But a lot of the phenomenon was happening in 2014 and 15.
Yes, so I think with all of these more reputable accounts, and they did ask him a question, I think, on quite a mainstream news network. The pointed question of, well, where do you think this has come from? So what do you think you saw? Is it just an advanced technology from the Soviets or whatever is it? And he said, what I saw wasn't from this Earth.
God. And this is a retired Navy commander?
He was a retired Navy commander, and he was a fighter pilot. Yeah.
God.
At the time.
So he's been around the block a few times in terms of seeing what the technology looks like from both US and Russian airspaces.
Yeah. What I saw was not of this Earth.
So from what I understood of that, I didn't see the interview itself, but from what I understood of the Navy reports, was the tic-tac shaped objects were reported as having supersonic speeds.
Yes.
And heights of 30,000 feet and above. But they had no visible engines, and they had no infrared exhaust plumes.
Yes, that was another key thing. So
And that was another key thing feeding into him saying this is not of our world.
Yep. Yeah, I think there was no clear propulsion system, and like you said, no infrared signal for any exhaust that might be coming in the opposite direction to motion. So it was, yeah, it's baffling, and I've watched it quite a few times on YouTube, and yeah, it baffles me. I have no explanation for that. And then another great Joe Rogan podcast was with Bob Lazar, whose account hasn't changed since he first started talking about it in the 80s. So he was hired, allegedly, in the late 80s to reverse engineer purported extraterrestrial technology, what he described to be a secret site called S4. And this is as part of it was apparently a sub-secret area within Area 51. And he claims he worked on alien craft and to reverse engineer and understand how these things worked. And he said the materials and the things he saw were just, first he went in and he saw this UFO just sort of sitting in the hangar. He's just like, oh. And it just had an American flag on it. So the Americans had claimed it already. But he sort of, chuckled to himself, laughed at himself, oh, this is what everyone's been talking about. It's just a really advanced aircraft by the US Air Force. And he actually touched it. And you remember, he even gave an account of when he went inside. And he said it was almost like when he was in, it was a small cabin. But the inside of it wasn't like there were any clear joints or bolts, no sort of clear way the components had been fused together. It almost looked like everything had been like gently melted. And that's the way he explained it back then in the late 80s. But like now, having understand injection molds and 3D printing, he was like, that's what it was. Obviously, that technology wasn't around at the time, but that's what it was. It was almost like an injection molded thing, which is why he sort of expressed that it had no clear joins or cracks or sort of visible differentiation between components and controls. It was all just this sort of melted one whole shell.
Where was it actually recovered from? Was that released at all?
So what he did find out was apparently, like, this is all very out there. I acknowledge that, but it's interesting. One of his colleagues he was working with claimed it was from another star system, and they had found these craft in a dig, and they found out also the beings that had these craft came to Earth and engineered with our ancestors' DNA, and they manipulated 64 genes to create Homo sapien.
What?
Yeah, so this is really out there. But it is weird how there's nothing. We're head and shoulders above anything else on this planet in terms of intelligence. But not that I'm ever suggesting that's the hypothesis. I mean, like we say, extraterrestrial should always be the last hypothesis, but it's always an interesting thought experiment.
Yeah, exactly. And that's what it really is, a thought experiment, isn't it? Yeah. So did what was the in his account, in the Lazar account, what was the aircraft used for going forward? Was it
He actually,
was it exhibited anywhere? Or?
No. It's in fact, he claims he studied at Caltech and MIT. There's no record of this, and it was wiped apparently. The fact he'd ever studied at Caltech and MIT, and in the documentary you can watch on Netflix, actually, it's called Bob Lazar and Flying Saucers, and it kind of just trivializes it a little bit, because what's amazing is this guy doesn't look like he's lying, and there's been a lot of people psychologists who understand sort of behavioral tics, and everyone's got to tell when they're lying in all these body language things. His story has been rock solid, consistent since the 80s till now, and he did the interview. I'd thoroughly recommend you see it if you haven't, on
I will do.
the Joe Rogan podcast. And I don't know, I feel like I'm quite a good judge of when someone's lying and when someone's being genuine. I find it hard to believe he's been fibbing for the best part of 40 years. or for 30 years.
with the completely consistent story.
Yeah, and he's not a guy who wants to get
no
anything out of
alteration.
this. He's not getting anything out of this. He doesn't like attention. He's a private guy. He's got nothing to. He doesn't stand to gain anything. He's not selling any books. He's not doing anything, and he's not looking for interviews. Joe had to beg him to get on there.
Right.
He's just a very sort of smart, nice, well-mannered man, and he very unassuming, very odd. It's all very strange. So sorry, back to your question, Leo, because I think I went off on a tangent. So he did see some test flights of these vehicles.
He saw some test flights.
Yes, he saw some test flights of these vehicles, and one of them was in front of him, and it just hovered off the ground at about a 2-meter height off the ground, with no noise, no exhaust, nothing.
And what was powering it? What kind of fuel?
So what he theorized it was that it was an anti-gravity of sorts, and you could almost direct this anti-gravity in any orientation you liked, and depending on what orientation you push the anti-gravity, it's almost like, because space-time, we're all on the space-time grid, if you like, and it dips down where there's a gravity pool or a hole in the gravity. So a black hole, which is the strongest gravity you can see in the universe, it would literally just be like a fulcrum going down. And so if you look at the sun's gravity, and if it's expressed on a space-time grid, it's almost like a fulcrum dip down. It doesn't obviously go down to a point like a black hole, but it's dipping down, and hence you can almost imagine the planets falling in. Like those things you get at the supermarket where you put the coin in and the coin flies around. It's very much like that. That's the shape of space-time, and that's why you get the coin orbiting, and that's the planet orbiting. That's space-time warped because of gravity.
Right.
Space-time is warped by gravity. And so what he theorized was there were generators of anti-gravity that almost created a gradient in space-time itself, and therefore it almost fell into the hole it's creating. Do you see what I mean? It's almost creating its fulcrum ahead of itself and falling into that fulcrum, into that hole in space-time.
I see. And that gives it some kind of lift or thrust.
Well, it's almost falling into the space-time distortion. So it's not really propelling itself. That's the wrong way to look at it. It's distorting the space-time in front of it so that it's constantly falling in that direction. Almost like a ball falls to Earth, but you can point it in any orientation.
I see. So it would not, it wouldn't be thrust. It would appear like thrust, but it wouldn't be
it
would
anything
move, that.
But there would be nothing would be, there would be no thrust. There would be no exhaust.
No.
And
bizarre.
Yeah,
bizarre.
He once saw one of them pushing its limits, where they were really doing a performance test, and this thing could perform 90-degree turns at supersonic speeds, and if on a conventional aircraft, that would just destroy the occupant, and he'd probably be smashed into just burst like a water balloon. But the way he explained it or theorized, he was like, I didn't understand how it would work, but then it made sense when I thought about the space-time warp. It's almost like it creates its own space-time, so it's unaffected by the surrounding gravity, and so it's almost meaningless. And in terms of its context, it almost creates its own space-time, so it's unaffected by even the most seemingly violent moves or maneuvers.
So it kind of creates its own, not like a force field, I suppose, but it creates sort of its own mini void, where it's sort of protected from usual rules of thermodynamics or
gravity.
The usual rules of gravity.
Yeah.
Again, I'm thinking of usual movement. But usual rules of gravity.
Yeah. It's all very fantastical, but it's always fun to talk about these things, isn't it?
Yeah. It's interesting to imagine forms of movement that are completely independent of the energy that we use to move things around, move people and payloads around. And what you were saying about how sort of the structure was welded together, and the relatability in modern times with 3D printing and things like that would definitely the 1980s have signaled this is something of another world.
And in terms of what he theorized might be fueling or generating this anti-gravity was something he referred to as chemical 115 or E115, which at the time hadn't actually been invented and it's now does exist on the periodic table, but at the time he was talking about it, it didn't exist as a element, and it was first synthesized in 2003, and it was named Moscovium.
Right.
Yeah.
But when he reported on it,
didn't exist.
It didn't exist, and that presumably that fortifies his account completely.
Yeah, I don't know. Yeah.
Well, it helps it at
helps
least.
It probably, yeah.
It helps him look like less of a fibber.
Yeah. And you could almost imagine if the anti-gravity it generated was sufficient, you could almost bend light around itself so it would be invisible.
Now, would that give it a huge amount of, I mean, not in terms of being invisible, but in terms of long distance, high speed travel, would that give it some I suppose some credence there? Would you be able to go long distances? We're talking, light years away, in relatively short times in a vehicle like that.
Yeah, I imagine so, because there's no I suppose finite fuel source you're using. There's nothing but the generation of anti-gravity, and I don't know whether the more anti-gravity you generate, the more element 115 you need. I have no idea. This is me talking about something very strange and very theoretical and fantastical, but I imagine, it doesn't rely on any sort of finite fuel source on board, so it could kind of travel indefinitely and probably close to the speed of light. And
that's where it gets very, very interesting, because one of the biggest objections, I mean, coming all the way back to the Fermi paradox, one of the biggest objections to being contacted by life on other planets comes down to the distance. And, with averages of between 7 and 17,000 light years away from Earth, you think, well, it's going to be impossible. The technology, even if we were to improve the travel technology by our standards, we'd be nowhere near, reaching those kind of distances. But maybe with an aircraft like that, it wouldn't be so out of the park.
We could, given enough time. So this is what I was saying right at the beginning. Given 1 million years, given our current rocket propulsion technology, we could populate the entire galaxy. But it would take 1 million years. So that's a big if. And then obviously then there's one thing for your galaxy, and then there's one thing to talk about the universe. So I think if we just focus on the galaxy for now, given our current understanding of physics and no fantastical sort of propulsion of the sort we were just talking about, we could, in theory, propagate our species throughout the galaxy in close to 1 million years, just using rocket propulsion or more sophisticated versions of rocket propulsion. Or basically, if I don't even want to go into rocket propulsion, I just want to say slower than light travel, we could do it within 1 million years. So it's not a must to invent some sort of anti-gravity propulsion system.
Yeah, you could get there with the means we have now, but you just need time.
Yeah, exactly.
And resources.
You just need time, resources, and the ability to colonize other planets, which we've not been able to demonstrate so far.
Now, would any of the resources on the moon help us in moving in that direction?
Yeah, the moon is quite resource rich, and I know there's one element on there referred to as helium-3, which could be used as a very clean fuel source. I think this was covered in the film Moon, which is actually really good. You should watch that. I think it's starred with Sam Rockwell. Yeah,
I've heard of that film. I haven't seen it though.
It's good. It's one of those films that sort of takes place in the confines of one small space station, or moon station. But it sometimes, so those films, it was set, with the right characters and a good script, are just great. They're so engrossing.
I'd love to see it. And does it delve into helium-3, or is it just about general resource mining on the moon?
It's just about the helium-3 mining operation that's going on there, and he's fine. Well, I'm not going to spoil it for you, actually. Spoiler alert. No, but yeah. So helium-3 is theorized to be there in abundance, and it's just a question of how you'd ferry it to and from Earth. And then, would you be able to do that in commercially viable quantities for it to make financial sense to do so?
Yeah.
But yeah, it's theorized that the first trillionaire would be a mining magnate who would look to the stars for the resources. I mean, there's already a company that's very seriously looking at mining asteroids.
Right. God. So how would that be possible? Because that presumably you've got to
catch up to it. Yeah.
Pretty far. Catch up to it. Have a lot of energy and a lot of the ability to travel very, very long distances.
Yeah. It would be like trying to land a fly on a speeding bullet.
Jeez.
Yeah.
Let's do it.
That sounds easy.
Yeah.
Let's go.
Well, at least you wouldn't be worrying about affecting the tides.
Well, exactly. You don't want to be diminishing the mass of the moon too much before it starts to float away. Well, the moon is moving away from us at the rate of 1.5 inches a year.
Really?
Yeah.
That's actually quite significant.
It is. It's going to stay up at night. Yeah, no, it's not insignificant. That's for sure.
No. So in about 30 years, it'll be, would you say 1.5 inches?
Yes.
Yeah. So in about 15 years, it'll be a foot away from us.
Yes. Oh no!
Don't go too far, Moon.
Come back.
Yeah.
No, if worse comes to worse, we could probably just put a gentle thruster on it on the other side and just inch it back, like.
Or maybe a giant fan. Like a fan boat, like a giant fan. That just blows it back
Leo,
into our
that
direction.
wouldn't work in the vacuum of space, now would it?
What? We need to simulate our own conditions.
Imagine
everywhere
you
we
did
go.
that and you found out when you got there, like, oh god, billions of dollars spent. What do we do?
You've constructed this giant fan the size of Wyoming. You're just like, oh, I can't wait to get this into action. And then just nothing happens. No noise, nothing at all.
But then, like, just to give the project some sense, you actually import vast quantities of oxygen and create an atmosphere just to make the fan work.
It becomes like
justify
the most
the
literal.
fan. We must justify the fan.
We must justify it. Cannot be a sunken cost. Pour more money into it.
We'll make it work.
Just digging a deeper and deeper hole. Financial and moral ruin.
Oh, that could happen.
Oh,
you never know.
We could give it a try. You never know. Dumber things have happened.
Oh, certainly have. And knowing this year, probably could happen.
Yeah. Anything. I mean, nothing will surprise me this year at this point.
But yeah, I think if we ever do find intelligent life, whether that's by us being proactive and finding something or them contacting us, I mean, some say we're just not showing the hallmarks of intelligence, and there's a lot of cases around the world to support that hypothesis. And until we do, we might not be accepted into the Galactic Senate. There is a genuine theory out there that says, or along the lines of, because we're not showing enough cooperation and we're showing some quite poor traits as a species, we've not met the threshold criteria to be contacted, and they're just waiting until we get there.
Well, there's a lot of reasons why that would be the case. I mean, if you were to observe our planet from another planet, we're a very unstable very, very unstable set of people, really. I mean, we're in a constant state of many, many different wars. We're very exploitative to one another and our own resources. And that's not to undermine all the positive things that have happened, because we really have been it's really been a fantastic journey. I think so much has been achieved by humans. But just sort of the net observation from an external standpoint wouldn't probably look too developed.
Yeah, probably from a type 2 or type 3 Kardashev civilization would certainly look quite primitive and not up to the task of being in the Senate just yet. But I think I think we need to give ourselves credit where it's due. It's amazing how this is the longest period of history where we've had true peacetime, no wars of any massive significance since World War II. And I think we've managed to organize society, economies. It's quite incredible, the complexity of these things and how everyone's able to get along and live a reasonable life and have a decent standard of living. And this is obviously the average person, not everyone does, but on the whole, we've managed to largely eliminate world hunger. We've managed to eliminate diseases like polio. And so I think sometimes giving ourselves more credit, and it's all too easy, and I think there's a very sort of common pop culture now to beat ourselves up for being these awful, no faith in humanity, my faith in humanity is over, I don't believe in it. But sometimes I think that needs to be tempered with a realization of how far we've come and what we've achieved. I think it's quite incredible.
Yeah, absolutely. I think there's been a huge degree of development, especially in the field of medicine, and the way that we've come in the past 100 years. You mentioned polio. I mean, there's things like tuberculosis and stamping out of diseases like smallpox and things like that. And then on the technological side, I mean, developments we've made going to the moon, the internet, all these amazing feats. Should never be underestimated. It's so easy to be negative about the human race, and most of the information we receive from the mass media is negative every day.
And I think we should lean on that side, because we should be that critical and we should strive to be better every single day. But I don't think it hurts to stop sometimes to realise how far you've come.
No, exactly. My question to you is, if anything like UFOs existed out there, or alien life form, what kind of politics could they be compatible with? Because I wanted to bring up the Posadas phenomenon, or the Posadism, the ideas of the Trotskyist thinker who postulated that if anything like UFOs did exist, they would demonstrate a very sophisticated level of technology.
Yes.
And that would have to be something that was compatible with what was advocated by socialism. So some form of mass equality. They'd be keen to address some of the major problems facing planet Earth. So would you be skeptical of that, Andre? Or do you think that there's something to say?
He thrust socialism upon them, didn't he? He almost gave it to them before they even knew what it was.
Yeah. It's it's a huge assumption. It's a huge assumption that aliens could only be socialists.
Aliens are communists.
Assuming that they could be anything. Commies! They're
coming. I think that would be the more terrifying thing for an American. Not that they're aliens, but that they're commies.
Yeah. The sort of McCarthyist. Oh, I don't mind that they're little green men with ray guns. I mind that they believe in intergalactic communism.
Well, Leo, I think there would be probably more aspects of socialism in their society than the right-wing conservatism. And I only say that because I think the likes of the means of exchange, money, inequality will be a thing of the past for a society that advanced, and it will almost be nonsensical. I think UBI, I think money as a thing or a means of exchange won't exist, at least in the same way we currently understand it. I don't think there will be any... I think there will be some level of inequality, but I don't think it will be sort of my net worth is X and your net worth is Y. It will be more on the basis of maybe upgrades, machine biology upgrades, that sort of thing. But then how do you afford those things? So I think there maybe will be some form of exchange, but I think it will be so different and alien to what we understand as dollars and gold.
Yeah. Well, these kind of methods of exchange will probably at that point be seen as so primitive and almost petty, really, sort of tit for tat. and very uncouth. Whereas if you're talking about things like Neuralinks and technological upgrades, maybe systems of barter or completely different systems of incentives that we can't even imagine will populate those societies, and yeah, dollars and gold will be seen as incredibly archaic.
Right, and I think ownership of physical assets, whether that's properties or just stuff, cars, vehicles, will be such a thing of the past. It would just be so meaningless to them. I think it will be the realm of the mind and the realm of consciousness that will be the sole investment of that kind of species. Physical possessions will be such a crude and primitive thing if you really think about it. You can already picture that now, really. Physical possession is weird, isn't it?
Well, I think already many people are seeing it as kind of a burden, and something that instead of enhancing them actually holds them back.
Well, Elon Musk sold all his houses recently, didn't he?
Right. And I still don't understand what. I mean, I do understand, the reasons he said he did that for, but I still don't fully understand why he did that.
I think it was partly the reason you just quoted there, that it felt like it was baggage, unnecessary baggage that was maybe holding him back a little bit, and also unfavourable press attention in that he has this many houses and these are the luxury villas he's got, and just kind of all of that unnecessary, just divorce himself from that, I think is probably a healthy thing. And I think particularly after this virus, and maybe we'll cover this in an upcoming podcast around consumerism, or maybe the death of consumerism, and almost a rebalancing of oneself from mental health and self-help and self-growth perspective.
Yeah. I think that'd be a very interesting angle, because consumption is not a static phenomenon. It changes so much, and it's a very sort of dynamic phenomenon. And again, I think on one of the upcoming podcasts we'll be looking into wilderness survival and bushcraft.
Yes.
And that is generally a movement that goes hand in hand with the relinquishing of big weighty possessions and liabilities, and things that are really more just survival based and in touch with one's more sort of primitive or spiritual happiness.
Oh, so true. Yeah, I think this really resonates or reminds me of a interview I saw with this futurist who talked about the importance, or what will become a lot more important in the future, and one of those things was the garden, and just a more of a connection with the earth, Mother Earth, and growing things, and just rekindling that bit sort of, I suppose, long lost connection that we always had. I remember as a kid digging in the garden in the mud and sort of digging a tunnel through the soil, and there was nothing sort of weirdly more I suppose satisfying than digging in the mud, and it was like a connection that is very hard to describe, and a deep satisfaction that is almost profound when you're just digging in the mud, and there's like this weird like peace that washes over you like a wave. And I just remember that. I remember digging in the garden. I used to do that a lot, and sort of like build things out of stone in the garden in the mud, and it's just like just you yourself doing that and being engrossed with working the earth. I don't know, it was a very strange experience.
No, I think you've got it in a nutshell there, really, and that inner peace that comes from that, it's sort of a form of self-sufficiency and connection to the earth or the things that you will use or sort of consume. And this has been noted by gardeners. It's been noted by people who've built super shelters from very primitive means and from the environment around them. It's also been noted by people in the hunting community and trappers in Canada and in the US. So these are, there's very, very much something special and peaceful when you completely take something from the earth, from the environment around you, and use it respectfully, in your own way to benefit yourself.
Yeah.
And that's always going to trump, going to a supermarket and buying food. Growing your own food is a very special and ritualistic experience. So, and I do totally see the futurist angle there of, okay, the garden is a very important thing to have. And it's almost beyond the realm of what a possession is or should be.
Yeah, I think it's a growing trend and something that we should only encourage. I think there's a lot of European countries that do it right, as in kids go out and there's not so much just the playground, but go out into the woods, the gardens, and experience nature as it's supposed to be experienced.
Yeah, it's incredible.
Nature as is intended, yeah. And it's just an unfiltered, unfettered, unsanitized experience.
And let's hope that alien life forms have cottoned onto that as well.
I'm sure they've all got lovely gardens.
In perfect diamond shapes, pentagonal shapes.
Yes. They get jealous. Oh my god, he's got a decahedron. I want one of those.
He's got a dodecahedron. I want his.
He's got a 4D decahedron.
Keeping Up with the Joneses continues on intergalactic levels.
Life. Oh my god, did you see what James got last week? He's got a Tesseract garden.
You know, we joke, but maybe there's a bit of that in everything and everyone out there.
I think it's probably true. I think it's probably a universal law, and it's weird because we are the universe, really. We are of the universe, and you and I and everyone are a product of 13.8 billion years of work. And we are the universe asking itself, what am I?
Yeah, absolutely. And that's something that Alan
And that's
Watts
not
talks
poetic.
about.
That's truth. That's complete truth. We are made of old stardust, and we are asking the universe, what am I? And is anyone else here?
What a beautiful poetic note.
Leo, it's been another absolutely blast of a conversation with yourself. It's been a pleasure and an honor.
It's been beautiful. It's been fantastical. It's been great. Fantastic exploration. Has been a journey.
It has been a journey. And perhaps the great British sci-fi writer Arthur C. Clarke said it best. Two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. And with that, thank you and good night. Over and out. Leo, thank you so much, my friend.
Thank you, my friend, and thanks everyone for listening. Over and out.
Pow! Pow!